All right, guys, Mr. Jenkins here with our, I think, last new lesson of the chapter, of chapter 5. That being said, we'll have a lot of stuff that we need to review before we get into like studying for the test or anything else, okay? So this is our last new lesson, though, and it's about parallel and perpendicular lines. All right, I think this is absolutely new, probably. In other words, you did not cover it in algebra, pre-algebra. All right, so anyways, let's go ahead and look at it. It says two distinct lines in a coordinate plane either intersect or are parallel. Parallel lines are in the same plane that never, parallel lines are lines in the same plane that never intersect, right? So, when your elementary teacher taught you about parallel lines, it's train tracks, right? Two lines that never cross. And so what we need to know about that, what we need to know about the slopes of parallel lines is that they are the same. You've probably heard this before. We talk a lot about it with systems, but slopes of parallel lines are the same. Which makes sense, right? We see those two lines, they're parallel, they appear to have the same slope, and they do. The slope of this one is 1/2. The slope of this one is 1/2, okay? So you can see why they'd never cross. And it says the same thing I just wrote up there. I just wanted to make sure that that's kind of the key idea, okay? So in problem 1, we're going to go ahead and try to write an equation of a parallel line. So there's the step-by-step process. I'll try to follow it, okay? Eventually you want to get away from like fill in the blank stuff, but it's good for notes. It's good for introducing the process. So here's the problem. This is what your test problem would say. A line passes through -3, -1, and it's parallel to y equals 2x plus 3. What's the equation of that line in slope-intercept form? Okay, so here's the easy part. It says identify the slope of the given line. So the slope of the given line is 2. Okay, I know that because it says 2 times x. The slope of any line parallel to this is also the same as that, so it would be 2. So it's as simple as that to know that, part of my final answer is going to be y equals 2 times x, just by looking at that. If I know, if it says parallel to this, then, and that's 2x plus 3, then I know my parallel line is going to start with y equals 2x. So that's the easy part. Okay, the tougher part, which you already know how to do, is now how do we make it go through a certain point? So step 2, write an equation in slope-intercept form with the slope m equals 2. Okay, so here should be your steps. We want to start with point-slope form. Okay, so I'm going to do that right here. Start with point-slope form. So in point-slope form, our x1 is going to be -3, our y1 is going to be -1, and m is 2. So remember, it is y minus y1, which we just said is -1, minus -1 shows up as +1, equals m, so 2, times the quantity x minus x1, which is -3. So that's going to show up as x plus 3. All right, so now what we need to do is, we already substituted. We're going to go ahead and solve for y, okay? So this reminds us to distribute first. So on the right side, 2 times x is 2x. 2 times 3 is +6. Then my last step is we need to move over the +1. Remember, I'm technically subtracting 1 from both sides, but the way I like to think of it is if it's +1 over here, it's -1 over there. Then we combine like terms. 6 minus 1 is 5. So my final answer is y equals 2x plus 5. Okay? So your last check could be, this was the easy part, coming up with the 2x. Your last check might be, if I plug in -3 here, do I get out -1, right? So if I just do that real quick, 2 times -3 plus 5 is -1, right? So we've written an equation that has a slope of 2 where I plug in -3 and it gives me -1. So that's exactly what we set out to do. All right. So let's see, what else do we have here? All right, I'm going to go ahead and do this next one too, just because this can be kind of tough stuff. Okay, I thought about leaving it for you, but I'll go ahead and do this. So let's write an equation in slope-intercept form of the line that passes through -5, 7 and is parallel, so same m to y equals -2/5 x minus 3. So right there, the only thing I care about from this part is what's my slope. M equals negative, make sure I read that right, -2/5, right? So I know in my final answer, it's going to start with y equals -2/5 x, right? So think about how I grade a test. It might be you get 2 points for the slope, you get 2 points for the y-intercept. Well, that'd be a pretty easy 2 points. And then worst comes to worst, you kind of maybe just guess at the end, right? Hopefully you know how to do it, but these 2 points are easy to get, okay? And when I say 2 points, I'm talking about grading a test. All right, so then we will use point slope. So we go y minus y1 is 7 equals m, which is -2/5, times the quantity x minus, and then x1 is -5, so it shows up as +5. Now, hopefully you can see, it probably seemed a little pointless, point slope at first, but now hopefully you can see, well, this can be kind of useful, right? It can be kind of useful. All right, so go ahead and distribute. So we get y minus 7 equals -2/5 x. Then -2/5 times 5, right? So here's where you would probably use your calculator, okay? So -2/5 times 5 is going to be -2, okay? So that's going to be -2. So y minus 7 is equal to -2/5 x minus 2, and then we just move over the -7. It's +7 on the other side. So that tells me that my coefficient, my b, is +5. Because -2 plus 7 is 5. Okay? And don't assume just because in this video both of our b's were 5 that happens every time. That's just a happy coincidence. All right, so parallel, pretty easy. Perpendicular, a little bit tougher. All right, so geometrically, what perpendicular means is they cross at a 90-degree angle. Okay, so that's a 90, that's a 90, that's 90, that's 90. Okay, now how do we do that algebraically? I know you can't read this, so I'll summarize. So the slopes of perpendicular lines are not the same. Okay, they are, if they were the same, they wouldn't cross. They are opposite. They're two things: opposite, reciprocal. Okay, so what's opposite mean? Opposite is in terms of sign, okay? So one's positive, one's negative. Reciprocal, that just means that you basically flip it, okay? So an example of reciprocals would be like, 2 and 1/2. Those are reciprocals. 2/1 and 1/2. That's where you flip it. Think about when you learn to divide by a fraction. You did keep, change, flip, right? So that is multiplying by the reciprocal. So opposite, reciprocal. This is the one that'll be a struggle. All right, so number 2 wants to know, are the graphs of 4y equals negative 5x plus 12 and y equals 4/5 minus 8 parallel, perpendicular, or neither? Actually, let's skip example 2 and come back and do that at the end, okay? So I think example 3 should actually be example 2. So we're going to write an equation of a perpendicular line. So it says a line passes through 1, 8. That's my x1, that's my y1 once I do that part. And it's perpendicular. So as soon as you see that, you think opposite, reciprocal. Okay? All right, so let's go through this a little bit quicker. So it's perpendicular to y equals 2x plus 1. All right? So the slope of that is 2. The opposite reciprocal of 2 is negative 1 over 2. Opposite because it's negative because negative is the opposite of positive, and then reciprocal of 2 over 1 is 1 over 2. So our perpendicular slope is negative 1/2. Now, once you know that, again, you know that your final answer is going to be y equals negative 1/2 x plus or minus something, right? Now, the last step is finding the sum. Okay, so let's go ahead and use point slope. So that'd be y minus y1 is 8 equals m, which is negative 1/2, times x minus, and then x1 is 1. Okay, and then the same process. Distribute, then add 8 to both sides. That's going to give me y minus 8 equals negative 1/2 x. And then your constant is going to be negative 1/2 times negative 1. If you're not sure what that is, just punch it in. Negative 1/2 times negative 1 is going to be 0.5 or 1/2. Okay? All right. Got a little lost there. So that'd be plus 1/2. And then we add 8 to both sides to move this term over. All right, so then 8 plus 1/2 is 8 1/2 or 8.5. Okay, 8 1/2 or 8.5. To make it look fancy, we'll call that 17 over 2. That's like 16 over 2 plus 1 over 2 is 17 over 2. I'd be perfectly happy with 8.5 or 8.5 there. Okay? So then your last one here. Write the slope-intercept form so we know y equals. Line that passes through 6 zeros perpendicular to y equals 3/2 x minus 6. So if m is 3 over 2, then we want the opposite reciprocal. Okay, so what would that be? So opposite of positive is negative, so it's going to be negative something. And then flip it, you get 2 over 3. So if you just know that part, you can at least get, some of the credit. Y equals negative 2/3 x plus or minus something. Okay? And then we just go from there. Point slope real quick. So you get y minus y1 is 0 equals m, which is negative 2/3, times the quantity, x minus x1 is 6. Okay, I'm going to let you go ahead and solve from there and finish the equation. All right, so the answer you should have come up with, and this is on the notes if you didn't get it, was it ends in plus 4. So final answer, y equals negative 2/3 x plus 4. Okay, and then we'll do maybe 1 or 2 of these last ones. Probably just do the last one. So back to example 2, are these parallel, perpendicular, or neither? So we can't really tell as is. What we'd want to do is we'd want to solve for y there. So on this one, we're going to divide both sides by 4. So that's going to give me y equals -5 over 4x plus 3. And then I can compare them, okay? So I'm just looking at their slopes, right? This slope is 4 over 5. This slope is -5 over 4. So that's opposite reciprocal. So we would just say that they are perpendicular. There's an old movie that I used to like. I think this was in Kindergarten Cop. They have this big chase scene, and it's a police chase scene, and they drive up this ramp. They're running away. It's a drawbridge, and they raise the ramp on them so they can't go anywhere. And Burt Reynolds calls it in, and he says, "Roger, we are perpendicular." I don't know. I always think of that when I see that word for some reason. I have to show you guys that if you remind me. All right. So anyways, I'll leave the last 2 for you. Those are in the filled out notes. We'll spend a few days on this, and then we will kind of start studying the chapter as a whole together. So make sure you're caught up on Math Excel. Make sure you're asking questions, staying engaged, doing whatever it takes. You guys have a good one.